wanted the bike to be designed in such a way where the rider could pedal or where the motor could pedal, either one. And it needed to be designed in such a way where you could be pedaling one moment and then the next moment the motor is going. And the next moment you decide to start pedaling again. It had to be very much back and forth, whatever the user wanted. And so two things. We needed the gear ratio to be right for that. And we also needed there to be one-way ratcheting sprockets that would allow the motor to spin without spinning the pedals, or for you to spin the pedals without turning the motor.
This time, sticking the motor in the frame triangle and driving the cranks, which we added freewheeling cranks, and then from there we're using the primary drive chain to take the power to the wheel.
With our current setup and our highest gear, we can get about 35 miles an hour top speed, and when we are in our lowest gear, we have enough torque to easily climb the steepest of hills. So we're really getting a full power range, and that's something we didn't see before when we didn't have our variable transmission.
So it's definitely not street legal, and it's fast.
So my job was to perform stress analysis on the transmission for this bicycle. We ran the bike full throttle from a dead stop in each gear to determine what the overall maximum torque was, and we found that the maximum torque was generated in fifth gear. I took the graph from the speed controller and determined where the maximum torque was, and then calculated the motor acceleration at the maximum torque. And then using the values at maximum torque from the speed controller graph, such as horsepower, motor RPM, and motor acceleration, I wrote a little program that allowed me to determine the torque in the shaft coupler down by the motor, the efficiency of our transmission, and the tension in the chain. I used this information along with FEMAP and NASTRAN to calculate the stresses in various components that were of concern. The calculated stress in the shaft coupler actually exceeded the limits of the aluminum that it was made out of. And it broke because there was too much torque on it.
Who was riding it when it broke?
I was riding it.
Okay. Just the availability of parts at a reasonable price was one of the biggest hurdles we had to overcome. Getting a motor that had decent power and decent efficiency and huge battery packs and the large speed controller at reasonable prices, that was tough. And then for this bike, I mean, getting gears, we ended up stealing the bevel gears from an angle grinder and the straight cut gears from another old hub motor, so we salvaged some good parts and made it cheap.